Hello everyone, welcome to my YouTube channel mathtrance. Today we are going to look into an amazing thing what our ancestors did with geometric progression. You'll be amazed to know that these guys knew how to solve a geometric problem, and that too for an infinite series. Let's get to it. So everybody knows what a GP looks like. It has terms like A, AR, AR square, AR cube, and so on. A sum of n terms is given by A 1 minus r to the power n 1 minus r. Okay, there's an interesting feature to this, that if r is less than 1 and as limit n tends to infinity for Sn, you know that as r is less than 1, this term will go to 0 when n tends to infinity. So it will become just this much. So now let's see what our ancestors did. They were like, this is the super coolest thing I've ever known. It is a part of Vedic mathematics. So for example, you need to calculate 1 by 19, say, right? What they used to do is approximate it to like 1 by 20. Okay, now you write it as this thing and keep on dividing, like, and divide zero point 0.1 by 2. You get a remainder of 1, and the remainder will be kept here below, and this will be the first unit, as the quotient is 0 and the remainder is 1, which is here. So now we look at like this. Now this is 10. So 10 divided by 2 is 5. Quotient is 5, remainder is 0. Now 5. For 5, we do the same thing. 2 is the quotient, 1 is the remainder. For 12, 6 is the quotient, 1 is, no, 0 is the remainder. 6, 3 is the quotient, 0 is the remainder. This, you can keep on repeating. Okay. And although we have done an approximation here, but this is not an approximation at all, because when limit n tends to infinity, I'll show you that it will exactly be equal to 1 by 19 and not something related to 1 by 20 or something. So 1 by 19 comes out to be 0 0.05, 2, 6, 3, and so on. You can calculate, and you can use your calculator to check it. It is very, very amazing. You should actually go and do something about with Vedic mathematics. You can see your mental calculations will be at peak. So how does the GP come into picture? See how creatively they used it. What if I write 19 as 20 minus 1? This is the same thing as 20 into 1 minus 1 by 20. Okay. Now, this thing is the same as 1 by 20 on 1 minus 1 by 20. You can see that a upon 1 minus r, if you compare it, then you get a equals to 1 by 20. That is the first term is 1 by 20. And the common ratio is 1 by 20 as well. Okay. So now, to express it, you just have to evaluate this sum. So 1 by 20 square. This is a, and this is r. So it will be 1 by 20 square. Then it will be a, this is r, this is r square, and so on up till infinity. Which means you just have to, this thing is what we started with. It is 0.1 by 2. Okay. And this is 0.1 by 2. And then again by 2. That is what we are doing. Continuously dividing this thing, what we get here, by 2. And this will give you, and because it is not 2, it is actually 20. So this 0 will turn out to give you the next decimal place. That is why this whole thing, when we did operation on this, so whatever the digit we got, we put it here in the next line. Okay, then the next one, right? And this is all continuing. So it is just that we just have to keep on successively dividing this. After whatever we get this, so what would this be? 0.1 by 2, 0.05, right? So when you divide this by 2, you'll get this term. The next will be this by 20. This will give you next decimal place, and you just have to perform this operation continuously. So therefore, whatever you were doing was perfectly all right, and it will give you the value of 1 by 19, which is the same as 0. Let me see once again, 5263. 5263. Not only this, you can extend it to 3 by 19 as well. Suppose 5 by 19 as well, any kind of fraction. Okay, and also for like not only 19, it can also be done for 18 as well. Just the thing is that you have to, in this case, your common ratio will be a bit different, right? When you subtract 20 from 2, therefore common ratio would be something like this, right? So this will change the method a bit. You have to multiply by successively by 2 for every term here, and then evaluate, which if you guys comment, I can post it on the next video. I hope you liked it. Do like, share, and subscribe my channel. Thank you.